Welcome back as we move on to discuss important points on how to use a DTI. One of the most important procedures is the so-called setup, so let's begin with this. In our demonstration, we shall be using a typical piece of precision equipment, namely a magnetic base and support assembly, onto which our DTI will be attached. As you may have to assemble the unit yourself, let's go through the procedures which, need we say, must be performed only in a clean work area. Looking at the base, the most obvious feature is the large on and off switch device. The base has two machined magnetic surfaces, which will attach the unit firmly to most steel surfaces when the switch is placed into the on position. A metal post, together with a non-magnetic washer, threads into the base. Do not leave the washer out, as this will prevent the magnet from being turned on or off. A universal clamp is assembled onto the universal arm. This, as an assembly, is fitted onto the main post and secured. Finally, the instrument support clamp is fitted to the universal arm as demonstrated. The dial test indicator itself has a back-mounted support bracket designed to hold the instrument upon a threaded supporting pin that has been attached to the outer clamp unit. The instrument is then secured with a thumb screw as demonstrated. Various angles can now be achieved simply by loosening the locks or the thumb screw and manipulating the DTI to virtually any desired position. We shall now, by way of a practical demonstration, learn how to put a DTI to use in a typical mechanical maintenance type of operation. What we want to determine is whether this chain sprocket is running true, or, if you prefer, whether it has any lateral runout. The operation begins as we prepare and set up our equipment. The first step is to make sure that the surface or component which is to be measured is perfectly clean. Any burrs, high spots or paint must be removed so as to present a lump-free surface. As we intend to use our magnetic base support assembly, we must first make sure that the surface onto which it will be placed is flat, clean, grease-free, and of course that it is made of suitable steel for a magnet. When the magnet is activated, the base should hold firmly. It may be necessary to scrape off paint to ensure a firm magnetic attachment. The next step is to manipulate the DTI into such a position that you can easily see the face and that the plunger makes contact against the sprocket wheel's facing. A very important point now is this. The plunger must be perpendicular to the facing, that is, coincident to any expected movement. Failure to do this will give an inaccurate reading. Note also that the plunger is placed as far from the shaft center as possible, but not so that it will slip into the teeth of the sprocket. All clamps and lock screws must be firmly secured, and a check made to ensure that the plunger is in fact contacting the wheel's facing. This can be verified by lightly tapping the gauge top and noting a small pointer deflection as you do this. Let's summarize the important basic setups for a typical run-out check. We must have clean surfaces. We need to have a flat, clean steel surface for the magnetic base. The DTI face must be placed so that you can see it clearly. The DTI plunger must be coincident or perpendicular to the expected movement. The plunger must be positioned as far as possible from shaft center. All locking devices must be firmly secured, and a check made to ensure that the plunger is actually in contact with the surface or facing. After the break, we'll look at how to take a run-out reading.